This is the MB Games Vectrex. It's the world's only vector-based computer games console. It came out here in the UK in 1983, which was just in time for the computer games crash, and so by 1984 it was gone. Inside, it's got a Motorola 6809 running at 1.5 megahertz. It's got 1 meg of RAM. It's got 1K of RAM. It's got 8K of ROM, and it takes 32K ROM cartridges. It has sound generated by, and I've got to look this up. It has sound generated by an AY-3-8910, which is the same sound chip that's used in the Auric 1, the Amstrad CPC, MSX and a whole bunch of others. It's also got an MOS 6522. Yay! This one doesn't work, so let's see if we can fix it. This machine belongs to my mate Matt, and we have had it on the channel before a long time ago when we took a look at it and we discovered that basically it doesn't work. You can power it on and it just does nothing. So I think we're going to open it up and we are going to have a look at the first two big suspects, and they are going to be the mains transformer and the power switch. Now this is interesting in the sense that the power transformer is connected directly to the mains and it is always live regardless of whether the machine is switched on or switched off. Now that's not such a big thing in the UK because we have switched mains sockets, and so you can easily switch it off at the socket. But it is an area prone to failure. So we're going to open it up and take a look inside. There are 4 screws in each of the corners. I'm not going to take them out because I believe they're actually of different length, and so I'm going to leave them in the appropriate hole. Once we hear them click, we know that they are actually unscrewed. Ah, there's another one there. A longer screwdriver. Go through all my screwdrivers at this rate. There we go. And off it comes. Now the thing you've got to be careful of this, it's got a CRT, and CRTs are basically dangerous. They can have up to 20,000 volts on them. I don't know what the voltage is of this one. It could be as low as 7 or 8,000. But it will give you a nasty jolt, whatever. So before we go any further, we are going to discharge it. I'd like to thank PCBWay for sponsoring this video. PCBWay make printed circuit boards. They make them in lots of different colours. All you need to do is upload your Gerber files and pick your colours and the number that you want, and they start from just $5 for 10 boards. And off you go. If you have never made a PCB in your life, they have shared projects like this where other people have designed various projects and you can just order it online, buy the boards. They will deliver them exactly like any other PCB. Job done. They've been going for 10 years. They are currently running their 7th annual design contest. You can win big prizes. Check out their website. Please check them out, www.pcbway.com. And this is my infamous Mac discharging tool. Now we can clip it to that earth. Okay, so I've put some gloves on, not because they will protect me from the electric, but mostly because this is kind of mucky and it gets kind of gooey over time, and it's protection as much as anything from the goo. Okay, so and you make sure that you contact the metal connector. It definitely is. Well, when I say we can lever it out, maybe we can't lever it out. Let's there we go. And yeah, you can see how gooey that is. So what we've got here is the transformer, the power switch. The power switch is actually mounted, soldered to this cable. So there are three electrolytic there are three electric caps on the logic board, and there are a load of electrolytic caps on the analog board, including two underneath this heatsink. We may well need to recap them. We will have a look. But I think the first thing to do is have a look at the transformer. And so actually before that we're going to take this subboard off, because I believe that is where the fuse is. And there we go, we can check that. It says it's a 250 milliamp slow blow fuse. And of course it's always live, but we will just beep it. And that is fine. So this, I think, is the secondary and the primary is underneath. So we'll need to get underneath where the mains cable comes in. And this transformer is screwed down to there. We can actually take this off. It comes with a built-in controller. Just plugs into one of the two ports there, and there is a spare one as well. This is the mains switch. Zoom into it. I'm not sure if you can see it. Oh. Tilt it back. So this is the main switch. This is reset. Click and twist. So we need to get that out. And I don't know if you can see that, but we're going to look at the transformer first to see if it's open circuit or anything. Because if it is, we will need to replace the transformer. Okay, we didn't need to do that. Because this is the primary winding, and we can measure it actually on the back of this board. So we need to take a smaller screw to take this off. And then we can measure across the back of it. We should see something like 30 odd ohms. Right, don't lose that screw. So we're measuring across there. That is the primary winding of the transformer. It's AC, so it doesn't really matter which way around. That's 8. Although I think it has different windings according to whether it's 240 volts or... So that's common, 220, and I guess that's 110. So that's the neutral side, that's the live side. So we need to measure between the red wire and the white wire because the black wire is common. And we're looking for 32-ish ohms. Sorry, it's that one, isn't it? 32 ohms. So the transformer is okay. We can put that back. We can reattach this because we didn't need to take it out. And so now we will look at the switch. Now we've got to figure out how to get this board out. There's one screw here. This is the switch. Actually, we probably don't even need to take that board out. We can look at the switch here and measure it. So I think what we should be seeing is nothing on between here and here. Correct. They are shorted together, and the switch, when we turn it on like that, should now connect these across. And no, it does not. So we've got a faulty switch. What I'm going to do is I'm going to spray some contact cleaner in there and give it a waggle for a while and see if that actually does anything for us. Trying to get an angle so that you can see. Right, what I've done is I've just pried the clasps back slightly just so that that opens it up a little bit so I can spray the contact cleaner in there. Spray some in there. Spray some in there. Just turn it around so I can get to it. Okay, and I'm just going to turn it on and off for a while, and we'll come back and we'll try it again. Okay, 10 minutes switching it on and off. repeatedly. Let's give it another try. So that's with the switch off. Switch it on. And there we go, 0.8 ohms. So the switch is fixed. I think there's really only one thing to do at this point, and that is to put the anode cap back on, seal it up and try it out. Okay, gloves back on because this is sticky. We just need to push that in. There we go. There we go. I won't screw it together for the time being. But that's good enough to protect. Take those off so I don't get goo everywhere. As is usual, the plug is switched off. The mains is switched off, so the plug goes on. And still nothing. So set that to beepy beepy. So the fuse is good in the plug. So it's not that. Now we have to start looking at other things. The back is off. The power is on. Now this connector has to be the main power supply to the logic board. It's coming from the voltage regulators, and I'm gonna guess it's got to be 12 volts and 5 volts. I will guess that the black one is earth. That's probably 5 volts or nothing. That's probably 12 volts or nothing. And that's nothing. So we've got nothing coming in. Now we can just have a quick look at the voltage input, which has to be coming into here from the transformer. So that's going to be something. No, it's not. Okay. Maybe the switch was intermittent or something. I think my brain was defective yesterday because I was measuring the voltage across these terminals and I had it set to DC volts, and no wonder it didn't show anything. So today, let's just recap. The switch is working, and we'll just show it working by going, it's not plugged in. This is one side. The red wires come from the transformer. The secondary windings, the white wire is the center tap. So it should be 9 volts center, 9 volts AC. So you can see this is currently 1.5. There we go. Put that at an angle so that you can see the display. 1.5 megs. Turn the switch. 0. So that's a good contact. Let's go to this side. 2.6 megs. Turn the switch. Good contact. Back off. So the switch is switching. I've measured the forward voltage across the rectifier diodes. They are fine. So now let's set this to AC volts. AC. And plug it in. Right. Turn it on. At this point it should be live. And we should see voltage across here. But we don't. So if we turn the power on, we should have voltage coming up to the rectifier diodes. So this is the input from one side to the center tap. AC volts, nothing. Other side to the center tap. AC volts, nothing. Turn it off, power it off. Unplug it. So I think possibly we have a faulty transformer. So what I'm going to do is take the transformer off and then see if, because sometimes these things have a fuse in them. I've had a look on RS, and a replacement transformer of this kind of spec is about 50 quid. Bit more actually, it's about 52 quid. So if that's got a fuse inside it, and some of these do have fuses inside them, then that would be a better and definitely cheaper option. So we're going to need to unsolder the secondary wires. So let me turn the soldering iron on. That's one. That's two. And I'm going to unsolder this one from here. There we go. So I think we may be able to unpry this. It looks like that might be a earth connection there. Now the worst case scenario is that this is potted, in which case there's not much we can do about it. But let's measure again with transformer completely isolated. So we should be seeing a low resistance between center and these. Yeah. Yeah. Okay. So maybe the problem is at the input side. Ah. Yep. So the black wire is not connected to either of these two. And that goes through fine. So this is the center tap, and we are connecting actually the black and the red one. So this transformer is open circuit on the primary. It's a few days later and the replacement transformer has arrived, so we can take a look. See what we've got. Oh, this is a big chunky one. So it's very similar in size. And I think no, it's not going to fit. Yeah, it's a bit too chunky. Okay, it's been a week or two because I ordered the transformer and I managed to get the wrong one, and so I had to order another one, and here it is. Hopefully it's the right one. Let's have a look. So it's encouraging that the lackey bands have perished. So we've got 4 wires on that side and 4 wires on that side. Most important thing, does it fit? Yeah, I believe it does. Dual primary 117 234 volts AC, 50-60 Hz. All units also have dual secondaries. Secondaries can be used as a center tap secondary, parallel connected, or used individually. So primary winding for 234 volts, which is what we have here. Well, 240. So on here, so let's take this off, because this is where our mains comes in. So we've got, going to the transformer, this side, we've got the plus, if you like, or the live connection. We've got the neutral connection, which is that one there, and then in the middle we've got the center tap, which is this one here. So we want to connect both white and black. White is a center tap, is a center tap, and orange is the neutral. It's an American transformer, I guess. They have weird colors in America land. So the way I read this, we need to connect, and I don't think that's going to go through that. We're going to need to strip some new connectors, I think. So white and brown go to that center tap, and then black goes to where the fuse is, and orange, which they separated their R's and their N's a bit better. Orange, because it does look like an M, goes to there. And then we can figure out what to do with the secondary. So I'm going to strip these off and make some new connections. Okay, so hopefully I can solder those to this little board. So this one, black, goes through the hole. Middle two are going to be white and brown. Oops. Actually, we can do these. White. And brown. And finally, orange, or as it says. So that's going to go into there. So we get that one. Okay, I've got it now. So I had the transformer the wrong way up, which really didn't help. So the primary needs to go in at the top, and the secondary comes out at the bottom, and that can then route to the switch. So that is all nice and safe and protected. So the reason I've got my drill bits out is I had to drill another hole for that to mount in, because that actually isn't quite the right diameter. It said 8 centimeters and it is not quite 8 centimeters difference. It's like 8 and a bit, or 7 and a bit. Either way, it wasn't quite right. Right, so that is now in. And we have to figure out how these are going to go on here. It doesn't particularly show live and neutral on the schematic, but here we can see, well, actually yes it does, because the fuse is in the live side, and that goes to this side, and this goes to D101 and D102, and the other side goes to D103 and D104. Now on here we've got, I don't know if you can see These are the 4 diodes. So these are the 4 diodes. D101 is at the top, D104 is at the bottom. Okay, so looking at these connections, we have 2 brown output sides corresponding to red and yellow, and in the middle is the system earth, and that corresponds to what was on the old transformer white, because that only had 3 outputs. And what I'm going to do is cut the white cable off, and we're going to use that because these, and it's blue and grey, are the center taps. So these need to join together and join onto this, and this is going to go back into where it came out of, which is there. So to join these together, at least for the moment, I'm going to use one of these. Okay, and that is going to go back into there. And I think we may well have to solder both sides. I'm going to. Some of these boards don't have plated through holes. Right, and I'm going to make clean connections on both of these, blue and grey. Then the other 2 wires go onto the switch. Okay, so this side is the live side, so that's going to be red. Then yellow goes onto the other one. Same procedure. There we go. And these 3 go into there. Tuck that away for the time being. How much money are you prepared to put on it working, and how much money on a big bang? I think the odds are evens either way. Now remember, the transformer is live at all times, so we're going to be extremely careful with it. Right, it's switched off at the mains. So here we go, 3, 2, 1. Mains is on, it hasn't gone bang. Blimey. Right, I'm going to set this up so that you can see the screen. Can you hear that hum? Right, I'm going to turn this light off. And I'm going to turn this light off. There we have it. Well, obviously it's a game, so I'm crap at it. So there you are. Yeah, that didn't last long, did it? So it's back up and running, and it's going to give many hours, I think, of continued enjoyment. There are plenty of games for it. There are upgrades for it. You can get a Pi module with cartridges. You can probably hear that horrible hum. I have got something that will fix that. Hopefully we will try that in another video. And it looks like there may be some wobbling on the screen. You can see possibly there on the Minefield logo. Is that failing capacitors? Because that's something else we can look at. Anyhow, thank you for watching. Please check out my Patreon. The details are in the description. My patrons are scrolling up the screen. If that is something that you would like to do to help the channel, then you are most welcome to. We don't have mid-roll ads on these videos, and my Patreon is part of the reason why we don't. So, game over. See you next time. See ya. Bye.